Hello everybody, here is your 2015 AP Calculus BC question number 1. We'll start by reading the question, and the question does say the rate at which rainwater flows into a drain pipe is this function R of t. Notice how the units are feet per hour. The pipe is partially blocked, allowing the water to drain out of the other end of the pipe at this rate. So this is where the water is going out, that's the rate, and this is where it's flowing into. So R is into, D of T is rainwater flowing out of it. There are 30 cubic feet in the water of the pipe at time 0. That means that's an initial condition. The question is, how many cubic feet of rainwater flow into the pipe during the 8-hour interval? So this question is just into, so that means that all I need to do is figure out an integral of this rate function. Remember, when you integrate a function, the units get multiplied. So since this is cubic feet per hour, and t is in hours, cubic feet per hour times hours is how an integral works. So pretty simple part for number 1. All you have to do is set up that integrand for that first point, and 0 to 8 because it's 8 hours time frame, and then plug this in. I would probably put this into my calculator since it is a sine function. You do absolutely need to make sure your calculator is in radian mode, and just set up that integral right in your calculator, and probably I'd be typing in f1 of x here as I would have entered this into my calculator. And that should give you an answer of 76.570. As we move on to question B says, is the amount of rainwater in the pipe increasing or decreasing? So to figure this out, R is the rate it's coming in, and if you subtract that by D, D is the rate that the rain is flowing out, this is going to be your total rate for change in water. Change in water, I don't know how else to say that, so I'll put delta W for the rate of the change of water. So this function, by putting them together, tells you if your amount of water is increasing or decreasing. So pretty simple question. You start by doing, since it's at 3, you do R of 3, and whatever answer that is, that gives you the rate water's flowing in, and you subtract that by D of 3. Since you do that, you get a negative answer. That means that the amount of water is decreasing. And you just need a little explanation with that, saying that that's less than 0. So you could absolutely consider the change, or you could just also, another way to consider the change is just showing that R of 3 is less than D of 3, and then that amount of water is decreasing. So as long as you considered this, now watch your notation, you must have an R of 3. Hopefully you didn't misinterpret that and do like R of t, but somehow, some way communicating R of 3 might, you need that at t equals 3 amount. And then, of course, you need to answer the question by saying it's decreasing because it's a negative value, or R of 3 is less than D of 3. So that's 2 points for that part of the question. As for part C, at what time from 0 to 8 is the amount of water in the pipe at a minimum? Well, this is an absolute minimum question, so right away you should be thinking candidate test. So as you think of candidate test, you're going to need to find when the rate is equal to 0. So basically you're going to start with R minus D. That's your rate for considering both the water coming in and the water coming out. So since this is your overall rate, the second this equals 0, that is a candidate that we need to test. And of course we also need to test its endpoints. So at 0 you have 30, and then at 8 you should probably check the amount of water also, and along with any of these critical points. So, first question, did you consider the critical points of R of t minus D of t equaling 0? And that's pretty easy to do on a calculator. You plug in maybe this into F1 and maybe this into F2, and then F3 can be F1 minus F2 in your calculator, and then you just need to calculate a 0. Of course, you could also calculate where these intersect, without doing that third function, and that will also give you the same answer as to when this equals 0. So the first thing you need to do, you need to consider that critical point. That critical point is 3.27165. Of course, you only need it accurate to 3 decimal places. So 3.271 or 3.272 is certainly acceptable. And then, of course, we get to our good old candidate test. So as we look at this in a whole, we're trying to kind of figure out where you have those possible maxes and mins. So you could do a lot of work here and talk about this being a minimum because the r of t minus d of t is negative to the left and positive to the right, therefore you have a minimum. You could do all that explanation, but the easiest way to do this is just through a little table in the candidate test. That's kind of how you're easily justifying absolute maxes and mins. So the first 30 I got from the given. This amount I got was basically calculating the initial amount plus 0 to t, and I would have stored my t value as this 3.271 or 272, and that would have been found on my calculator by doing this calculation and storing this as a 0. And then 8, of course, is your endpoint. So if it goes 0 to 8, this is right here, this amount indicates your change in water. So the starting amount is 30, whatever answer this is for ending at 3.27, and then redoing it with ending at 8. That gives you your total amount, and then the minimum, of course, is the smallest of these 3 answers. Best to do this via the candidate test. And then I did show this Desmos slide here of calculating the r of t of d of t minus 0, and here is that point I would have used on Desmos, but of course you would have did it on your graphing calculator, and that's how it should look to get this 3.272 answer. As for part D, a little bit more challenging here. The pipe can hold 50 cubic feet of water before overflowing. Water continues to flow in and out of the pipe at given rates until the pipe overflows. Write, but do not solve, an equation, so you have to have an equal sign, unpack your words here, involving one or more integrals that gives the time w when the pipe begins to overflow. So you don't really know the time, so that's why it's best to kind of put that ending point as a I just don't know. Let's call it w, because it basically tells me that it's w. This here is the beginning amount of water, and the answer to this integral, kind of similar to part C, is basically going to be how much water is added. This is the added water amount. And as soon as that gets to 50, you're going to overflow. So whatever I'd solve this for the w, you can have an unknown in your upper bound. That amount total here of water in the drain pipe will then reach that magic point of 50, which is the overflowing point. Here's my first video. I hope it all worked out for you. Good luck, everybody. If you need some help, please contact me.